All right, fellas, we're on topic 61, the mean value theorem. Now, before I get started on this, I know you're going to be asking yourself, well, probably ask yourself all the time, but you're going to ask yourself, why is this important for calculus? And as for right now, I don't know. Okay, so before you ask me that question, don't, so I don't know. So, but we're going to do it anyway. It's part of the test, so we'll see what happens. All right, so here's the formula for the mean value theorem for integrals. Notice it's just the integral between a and b times 1 over b minus a. Now b minus a is the width, basically is the width of the rectangle. All right, so the average value of f of x is the height of the rectangle with the base b minus a, whose area equals the area under the graph of f of x between x is equal to a and x is equal to b. Alright, so what does that mean? Basically, this is the area right here that they're talking about. Okay, so I'm not really sure why that's important. I'm guessing they had to do it a lot back in the day, but anyway, I don't know. So on this one right here, right, they're asking us to find the average value of f on the interval between 1 and 3 and interpret the results geometrically. So the average value of f, and again I'm doing this with a pencil, there's a lot of room for error here, so 1 over 3 minus 1 now remember that 3 minus 1 came from this interval. The integral between 1 and 3 of f of x, in this case f of x is x squared dx. Alright, so the actual math of it is not very hard. It's actually pretty simple, just like the last problem we did, except for we have this 1/2 now. The 1/2 came from 1 over 3 minus 1. So we have 1/2. The integral of x squared is x cubed over 3. Are we going to find the values between 3 and 1, or the values of 3 and the values of 1? So that would give me 1/2. 9 minus 1/3, which is equal to 1/2 times 26 over 3, which is equal to 13 over 3, which is equal to 4 and 1/3 actually. Okay, so alright, so again what we just found is the height. So this is the height of the rectangle. Now the rectangle that we're talking about is this one between 1 and 3. Well, actually I have to do a little bit more work before I find out this on paper. But anyways, this is the height of the rectangle, or the mean value. Now remember that this right here, the 3 minus 1, is the width of the rectangle. Rectangle. And then, well, hopefully you know what that means, which is the area under the curve. Okay, so, to figure out the rest of this, alright, if the original equation was x squared is equal to y, and that's the height of the rectangle, was 4 and 1/3. Let me write it as 13 over 3 because it's going to make it easier. X squared is equal to 14 over 3. 13 over 3. We're going to take the square root of both sides, and that's going to give us plus or minus the square root of 13 over 3, which is the same thing as plus or minus 2.082. However, the negative, a negative 2 is not in the interval. So again, all we have Therefore, is that at 2 point something something, the height of that rectangle, of this rectangle, is 4 1/3. So again, the height is 4 1/3. Right, and again, I'm not using the negative of it because this is not in the interval between 1 and 3. Oh, sorry, the interval of 1 and 3, 1 and 3 included. Okay, so that's that for this page. Again, I'm not really sure what this accomplishes. Hopefully that'll become apparent to me as we continue with this class. Now let's go to the back of this. All right, example 2. All right, they're asking you to do the same thing. They're trying to ask you to find the average value, which we know is 1 over 4 minus 1. Again, that 4 minus 1 came from the interval. You're going to take the integral between 1 and 4 of 3x squared minus 2x dx. So it's going to be 1/3 x cubed minus x squared. Again, I took the integral just now. We're going to evaluate it at 1 and 4. Alright, then after that, we're going to find all the values of x and the interval for which the function equals its average value. Okay, so I'll tell you what that means in a second. However, let's go ahead and finish this one. We have 1/3. Let me put a bracket here. We have 64 minus 16 minus 1 minus 1. That's going to give us 1 over 3. Notice that's going to be 0. This is going to be 48. So we have times 48, which is equal to 16. So this is the average height or the y value. Okay. Now, to figure out all the values of x, all right, all the values of x in the interval for which the function equals its average value, what we actually have to do is, this is my y, all right, so I'm going to set 16 equal to 3x squared minus 2x. Now, on this, you can use the calculator if you want to. This one's not terribly hard, but if you have to use the calculator to solve for something like this, that's okay. But since I already solved this by hand, let me at least write it down. So again, if you have to solve this with a calculator, that's fine. And just make sure that whatever values you have, in this case you're going to get a -2 and a 8 over 3. Make sure they're in the interval. And notice that in this case, -2 is not in the interval. Okay, so we found all the values of x. Alright, so both of these are your answers because they're asking us for both of those. Now on example 3, alright, example 3, there is nothing new about this. They just this is actually a review from the last few lessons. So again, they're not asking you to find the average value of anything. We're just going to take the integral of that. And these are the boundaries that are given to us. So just make sure you understand the boundaries. The y is equal to 0 is actually the x-axis, right? Now, again, did I say y is equal? I meant to say x. Wait, I'm thinking. Yeah, y is equal to 0 is actually this. Now they want to know between 0 and 2. So on this, let's say that this graph looks like that. Right, they just want to know basically the integral between 0 and 2. That's all they really want to know. Okay, that's all. So again, y is equal to 0 is the x-axis. X is equal to 0 is actually this line right here, and x is equal to 2 is this line. So we're just going to take the integral of that. So if you can see how that works, then all we're really doing is taking the integral of 2x squared minus 3x plus 2 dx, and this definite integral is between 0 and 2. So this shouldn't be a big deal. You add 1, divide by the same number, so we got cx cubed, so that's going to give me 2x cubed minus 3x squared over 2 plus x, and I read plus c instead, my apologies, plus 2 plus 2x. We're going to evaluate that at 2 and at 0. And when we do, we'll get 16 minus 3 minus 6 plus 4, all of that minus 0. Because if you plug in a 0 here, it's 0. And that's going to give you 10, let's see, 16 over 3. Let's see, that's negative 2 minus 6/3. Yeah, negative 2 is the same thing as 6/3, which is equal to 10 over 3. Okay, and that should be it. Now, make sure to check this in your calculator, right? So check on the calculator. Now, on your homework, though, let me just say a couple of things about your homework on 61. Right, I'm going to try to do my best not to show you all the answers. Right, if you look at, and you can only hear my voice here, but if you look at 1 through 5, all you're really doing is just taking the integral, just like you've done in the past. Where you start doing the mean value theorem is in problem like number 6, right? So let me show you what you're actually doing is you're trying to find the x value. So when it's actually talking about find the value of c, this is the x like we found in the notes, alright? So first things first, you find the average value here. And you do that by doing, 2 minus 0, here's that, and then you take the integral of this. When you do blah blah blah, you get this answer, which is the average value. Okay. Now to figure out the x value, you're going to set that number equal to this function. Now to find that, the reason I'm showing you this is like, yes, you don't have to do this by hand. Do this on the calculator. And make sure that whatever values you get here are in this interval. Alright, in this case, both of these are in the interval, so that's the answer. Okay. Again, take a look at that. I hope you're doing well. And again, if you got questions, make sure you contact me via Twitter if you can.